So hello and assalamu alaikum friend. My name is Mohammed Ali. I am student at Rehan School Islamabad campus, level 1 student. So today we interview with Colony. My Colony interview topic is science and physics course. So viewers, let's start our ChatGPT interview. Hello ChatGPT, can you hear me?
Yes, I can hear you. How can I help today?
Okay ChatGPT, my first question for you
I'm here.
is my first question for you is what is the matter made of?
Matter is made up of tiny particles called atoms. Atoms consist of a nucleus made of protons and neutrons with electrons orbiting around them. These atoms combine to form molecules, which make up all the substances we see around us. Anything specific you're curious about?
Okay, okay, ChatGPT. My next question for you is, what are the three main states of matter? Give me long and proper answer.
Sure, the three main states of matter are solid, liquid, and gas. 1. Solid. In a solid, the particles are closely packed together in a fixed, orderly arrangement. This gives solids a definite shape and volume. The particles in a solid vibrate in place but do not move around freely. 2. Liquid. In a liquid, the particles are still close together but can move around each other, allowing liquids to flow and take the shape of their container. However, liquids have a definite volume but no fixed shape. 3. Gas. In a gas, the particles are far apart and move freely at high speeds. This allows gases to expand, so solids have a fixed shape and volume. Liquids have a definite volume but take the shape of their container, and gases expand to fill their container with no fixed shape. Each state has unique properties based on how the particles interact with each other.
Okay, ChatGPT, great answer. And my next question for you is, how does matter change from one state to another? Please give me long and proper answer.
Certainly, matter can change from one state to another through physical processes known as phase changes. Here are the main phase changes. 1. Melting. This is the process where a solid turns into a liquid. When a solid is heated, its particles gain energy, causing them to vibrate more and eventually break free from their fixed positions, turning into a liquid. 2. Freezing. Freezing is the reverse of melting. It occurs when a liquid turns into a solid. As the temperature of a liquid decreases, its particles lose energy, move closer together, and form a fixed structure, resulting in a solid. 3. Vaporization. This phase change occurs when a liquid turns into a gas. There are two types of vaporization: evaporation and boiling. Evaporation happens at the surface of a liquid at temperatures below its boiling point, while boiling occurs throughout the liquid at a specific temperature. In both cases, the particles gain enough energy to break free from the liquid state and become a gas. 4. Condensation. This is the process where a gas turns into a liquid. When a gas loses energy, its particles come closer together and form intermolecular attractions, turning into a liquid. 5. Sublimation. This is when a solid changes directly into a gas without passing through the liquid state. This happens when the particles of a solid gain enough energy to overcome their intermolecular forces and transition into a gas. Each of these phase changes involves either adding or removing energy, affecting the behavior and arrangement of particles in the matter.
Okay, ChatGPT, very good answer. And my next question for you is, what is the difference between mass and weight? Give me long and proper answer.
Of course, mass and weight are related concepts, but they are not the same thing. Here's a detailed explanation. 1. Mass. Mass is a measure of the amount of matter in an object. It is a scalar quantity, meaning it has only magnitude and no direction. Mass is an intrinsic property of an object and does not change regardless of its location in the universe. It is typically measured in kilograms, kg, or grams, g. 2. Weight, on the other hand, is the force exerted on an object due to gravity. It is a vector quantity, meaning it has both magnitude and direction. Weight depends on both the mass of the object and the gravitational acceleration acting on it. The formula to calculate weight is equal to mass times gravitational acceleration. On Earth, the gravitational acceleration is approximately 9.8 meters per second. Weight can change depending on the gravitational field strength. For example, an object will weigh less on the moon than on Earth because the moon's gravitational acceleration is weaker. To summarize, mass is the amount of matter in an object and remains constant regardless of location, while weight is the force of gravity acting on that mass and can vary depending on the gravitational field strength.
Okay, ChatGPT, very very good answer. And my next question for you is, what are atoms and how do they relate to matter? Give me good answer and long.
Certainly, atoms are the basic building blocks of matter. They are the smallest units of an element that retain the properties of that element. Structure of an atom. Nucleus. At the center of an atom is the nucleus, which contains protons and neutrons. Protons have a positive charge, while neutrons have no charge, neutral. Surrounding the nucleus are electrons, which have a negative charge. Electrons move around the nucleus in regions called electron clouds or orbitals. Relation to matter. Elements and atoms. Elements are pure substances made of only one type of atom. For example, a gold atom is the building block of gold, and an oxygen atom is the building block of oxygen. Molecules and compounds. Atoms can bond together to form molecules. A molecule is the smallest unit of a chemical compound that retains the compound's chemical properties. For example, a water molecule, H2O, consists of two hydrogen atoms bonded to one oxygen atom. Matter. All physical substances in the universe are made up of atoms. The properties of matter, such as its state, solid, liquid, gas, are determined by how atoms are arranged and how they interact with each other. In summary, atoms are the fundamental units of matter. They combine in various ways to form elements and compounds, which make up all the materials and substances we encounter in the world.
Okay, ChatGPT, good answer. And my next question for you is, how do solid, liquid, and gas behave differently? Give me long and proper answer.
Absolutely. Solids, liquids, and gases each have distinct behaviors based on how their particles are arranged and how they interact with each other. 1. Particle arrangement. In solids, particles are tightly packed in a fixed, orderly pattern. This close arrangement gives solids a definite shape and volume. Particle movement. The particles in a solid vibrate in place, but do not move around freely. This limited movement is why solids maintain their shape. Because of their fixed structure, solids are rigid and cannot flow. They also have a definite volume, meaning they do not change shape unless a force is applied. 2. Liquids. Particle arrangement. In liquids, particles are still close together, but not in a fixed position. They are loosely packed, allowing them to move around each other. Particle movement. The particles in a liquid can slide past one another, which allows liquids to flow and take the shape of their container. Behavior. Liquids have a definite volume, meaning they do not change volume easily, but they do not have a fixed shape. They adapt to the shape of their container. 3. Gases. Particle arrangement. In gases, particles are far apart and move freely in all directions. This spread out arrangement allows gases to fill the entire volume of their container. Particle movement. The particles in a gas move rapidly and randomly, colliding with each other and the walls of their container. Behavior. Gases have neither a definite shape nor a definite volume. They expand to fill the entire space available to them and can be easily compressed. Comparative behavior. Shape. Solids have a fixed shape, liquids take the shape of their container, and gases have no fixed shape. Volume. Solids and liquids have definite volumes, while gases do not. Compressibility. Solids are incompressible, liquids are slightly compressible, and gases are highly compressible. These differences in behavior are due to the varying interactions and energy levels of the particles in each state of matter.
Okay, ChatGPT, very very good answer. And my next question for you is, what is the plasma and how is it different from other states of matter?
Great question. Plasma is often referred to as the fourth state of matter, distinct from solids, liquids, and gases. Here's an explanation. Plasma. Definition. Plasma is a state of matter where gas-like substances are ionized, meaning that a significant number of its atoms have lost or gained electrons, resulting in a mixture of free electrons and ions. This makes plasma electrically conductive. Formation. Plasma is formed at extremely high temperatures or when energy is supplied to a gas, causing its electrons to separate from their atoms. Differences from other states of matter. Particles. In plasma, the particles are ionized, consisting of free electrons and positively charged ions. In contrast, particles in solids, liquids, and gases are neutral and not ionized. Energy levels. Plasma requires much higher energy to form compared to the energy needed to change from solid to liquid to gas. Conductivity. Because of the presence of free electrons, plasma is highly conductive and can carry electric currents, unlike solids, liquids, and gases, which are not as conductive. This property is not present in solids, liquids, or gases at very high temperatures, such as those found in stars, including the sun, or in controlled laboratory conditions. Plasma versus other states of matter. Solids, liquids, and gases are composed of neutral atoms.
I'm sorry, but you've hit the daily limit for advanced voice. You can switch to standard now to keep chatting.
So here he says our professional voice is ended. So we switch it to standard voice. Okay, get started. ChatGPT, my question for you is, what is the plasma and how is it different from other states of matter?
Plasma is a state of matter where gas is ionized, meaning it has free electrons and ions instead of neutral atoms or molecules. This happens when energy is added, often at extremely high temperatures, causing electrons to be stripped away from atoms. Plasma is highly conductive and can carry electric currents, unlike solids, liquids, and gases, which consist of neutral particles. The key differences from other states of matter are particles. Plasma contains ions and free electrons, while solids, liquids, and gases have neutral atoms or molecules. Energy. Plasma requires much more energy to form than solids, liquids, or gases. Conductivity. Plasma is electrically conductive, while the other states are not. Temperature. Plasmas typically exist at much higher temperatures, like those found in stars or in plasma TVs.
Okay, ChatGPT, good answer. And my next question for you is, what is dark matter and why is it
I'm glad you
important?
like the answer. What's your next question?
Okay, ChatGPT, my next question for you is, what is dark matter and why is it important in physics? Give me long and proper answer.
Dark matter is a mysterious and invisible substance that makes up about 27% of the universe's total mass and energy. Yet we cannot see it directly. It doesn't emit, absorb, or reflect light or any other form of electromagnetic radiation, which is why it's called dark. Although we can't observe dark matter through traditional means, scientists know it exists because of its gravitational effects on visible matter. What is dark matter? To understand dark matter, we first need to talk about gravity. In our universe, we observe how galaxies move. When we look at the outer regions of galaxies, the stars move much faster than we would expect if only visible matter, like stars, planets, and gas, were present. Based on the visible matter we see, galaxies should be rotating slower, and they should break apart due to the lack of enough gravitational pull. However, this doesn't happen. Instead, galaxies remain intact. This led scientists to conclude that there must be some invisible mass that exerts gravitational force, pulling on the galaxies and keeping them from flying apart. This unseen mass is what we call dark matter. Scientists have also detected its presence in other ways. For example, when we look at clusters of galaxies, the gravitational effects of dark matter cause light from distant objects to bend around them in a phenomenon known as gravitational lensing. This bending of light suggests the presence of a large amount of mass that cannot be seen. Moreover, dark matter impacts the way the universe has formed. Computer simulations of the universe's evolution indicate that dark matter played a crucial role in shaping the distribution of galaxies and clusters of galaxies. What is dark matter made of? The exact composition of dark matter is one of the biggest mysteries in physics. It's not made of the normal matter we encounter every day, like protons, neutrons, and electrons. Instead, scientists believe dark matter consists of particles that do not interact with light or normal matter in the way that ordinary matter does. Some leading candidates for dark matter particles include weakly interacting massive particles, WMPs. These are theoretical particles that could be heavy, but interact very weakly with normal matter. If they exist, they would be a type of subatomic particle that only interacts with gravity and the weak nuclear force, making them invisible and hard to detect. Axions. These are hypothetical very light particles that could also explain dark matter. They were proposed to resolve certain issues in particle physics and might be abundant in the universe. Sterile neutrinos. These are a proposed type of neutrino that doesn't interact via the weak force, the type of force normal neutrinos interact with. If they exist, they could contribute to dark matter. So far, no one has definitively detected these particles, but experiments are ongoing in hopes of discovering their presence. Why is dark matter important in physics? Dark matter is crucial for understanding the structure and behavior of the universe. Here are several reasons why it matters. 1. Understanding gravity and the universe's behavior. Dark matter's gravitational effects are essential for explaining why galaxies and galaxy clusters behave the way they do. It helps physicists understand how gravity works on cosmic
रात है उठ
scales.
नहीं सकता.
Without dark matter, many cosmic phenomena simply wouldn't make sense. 2. Formation of the universe and galaxies. Dark matter is thought to have played a critical role in the formation of galaxies and larger cosmic structures. Shortly after the Big Bang, dark matter's gravitational pull helped clump normal matter together, allowing the first stars and galaxies to form. Understanding dark matter helps physicists recreate the evolution of the universe and explain its current structure. 3. Potential new physics. Dark matter challenges our understanding of physics. The standard model of particle physics, which is the theory that explains the fundamental forces and particles of the universe, doesn't account for dark matter. Discovering what dark matter is made of could lead to new physics beyond what we currently know. It may unlock answers to fundamental questions about how the universe works on the smallest and largest scales. 4. Dark matter and the fate of the universe. The discovery of dark matter could also have implications for the fate of the universe. Some
या तो
theories
वीडियो
suggest
कॉल
that
आपके
dark
बनाया
matter
जाए
could
इसके ऊपर रखो
influence the expansion of the
मुझे
universe,
खाना खाने बैठ
which
गए
is currently accelerating. This acceleration is driven by another mysterious force
एक
known as
रुपये
dark
बचा देख रहे हो
energy. But understanding both
नहीं
dark
जिससे
matter
जो रख
and dark
वो
energy
देख रहे हो
could
क्या
give
जो
us
कि ये पता
insight
नहीं क्या
into
लगता है
how the universe will evolve in the future. 5.
चोरी करके देख
Unsolved
लो
mysteries. Dark matter
यहाँ पे रखो इसको
ChatGPT, please answer my question.
काम किया आपके सारे
Sorry viewers, a little problem. We continue our ChatGPT interview. Hello ChatGPT, can you hear me?
Yes, I can hear you. What's on your mind?
Okay ChatGPT, my next question for you is how does temperature affect the state of matter?
Temperature plays a crucial role in determining the state of matter because it affects the energy of the particles within a substance. When the temperature changes, it alters how fast the particles move and how strongly they interact with each other. which in turn causes changes in the state of matter. Here's how temperature affects each state of matter. 1. Solids. In solids, the particles are closely packed together and vibrate in place. As temperature increases, the particles gain more energy, causing them to vibrate more vigorously. If the temperature increases enough, the solid can melt into a liquid. For example, when ice is heated, the particles move faster and the solid turns into water. 2. Liquids. In liquids, particles are still close together but can move around each other. When the temperature rises, the particles gain more energy and move faster, making the liquid expand. If the temperature continues to rise, the liquid can reach its boiling point and turn into a gas. For example, when water is heated, it eventually boils and turns into steam. 3. Gases. In gases, the particles are far apart and move freely at high speeds. When the temperature increases, the particles move even faster and spread out more. Conversely, if the temperature decreases, the particles lose energy and slow down. If cooled enough, gases can condense into liquids. For example, if water vapor is cooled, it condenses into liquid water. In summary, increasing temperature generally causes particles to move faster, potentially changing a substance from solid to liquid to gas. Conversely, lowering the temperature reduces particle movement, leading to a change from gas to liquid to solid. This is why heating or cooling substances can lead to phase changes, such as melting, freezing, evaporation, and condensation.
Okay, ChatGPT, thanks for your answer. And my next question for you is, what is the law of conservation of matter? Please give me long and proper answer.
मुझे लगता है कि कुछ अल्फाज या जमले वाज़ेह नहीं हैं। क्या आप दोबारा सवाल पूछ सकते हैं? या फिर
Okay,
इस बात को मज़ीद वाज़ेह कर सकते हैं कि आप क्या जानना चाहते हैं?
okay, ChatGPT, please speak English. And my question for you is, what happened during condensation of evaporation?
Sure, I'll explain both condensation and evaporation. Evaporation happens when a liquid turns into a gas. This occurs when the molecules of a liquid gain enough energy, usually from heat, to break free from the surface and escape into the air. Even at temperatures lower than the boiling point, some molecules near the surface can still escape because they have enough energy to overcome the forces holding them in the liquid. This process happens slowly and is why we see water disappearing from a puddle or clothes drying in the sun. On the other hand, condensation is the opposite process. It happens when a gas turns into a liquid. This occurs when the gas cools down, causing the molecules to lose energy and slow down. As a result, the molecules come closer together, forming liquid droplets. This is what happens when you see water droplets on a cold glass or the formation of dew on grass in the morning. In short, evaporation, liquid to gas due to heat or energy. Condensation, gas to liquid due to cooling or loss of energy.
Okay, ChatGPT, thanks for your answers. And we end our recording. Okay, bye.
You're welcome. It was a pleasure answering your questions. Take care and feel free to reach out anytime. Goodbye.
Goodbye. So here, this is our ChatGPT interview. I hope you like it, and a new topic and new interview. Allah Hafiz. Pakistan Zindabad.